Hey everyone, welcome back to my number sense series. In this video, we're going to be talking about counting subsets. Now, really the hardest part about this video is understanding what a subset is. And once you know what the formula is for these kinds of problems, it's going to be super easy. But in order to understand the formula, we have to understand the language that we're using. What is a subset? Well, a subset is a set. And what is a set? Well, in mathematics, you can loosely define a set as a collection of things. This is not really a great definition of set once you learn more set theory, but this is generally how sets are introduced. A collection of things, a collection of anything. So for example, three, the letter A, and a drawing of a dog. Don't look too closely, but that's a drawing of my dog, woof woof. Okay, a set can really contain anything. But usually it contains numbers, or something along those lines. A set can also importantly contain other sets. But none of that really matters for what we're doing, because we care about subsets, and more specifically, counting them. Now, a subset is another set that is kind of an extension or a part of another set. For example, if this is our original set, 3 might be considered a subset because every element of this set is an element of the original set. That's the definition of a subset. A set where every single element of that set is an element of the original set. So here we have 3 as a subset. We could have 3, comma A as a subset. We could have A, comma dog as another subset. We could also have nothing as a subset. For example, we could have the empty set, this set that literally contains nothing, that is also a valid subset, and we could also have the entire set as a subset. All of these are valid subsets of our original set. But the issue is, how can we count subsets? Well, let's see that with an example problem. So for example, if we wanted to count the number of subsets of this set, TRIAL, well, the naive approach would be to simply list out all the subsets, and while that's not a good approach, it can give us some insight. But let's start with smaller cases. For example, how many subsets are there of the letter T? Well, of course we can have the set itself as a subset, as we've said before, and we can also have the empty set. We either have one element or 0, and we only have one choice for either of those cases. So here we have 2 subsets. Now, what about TR? And of course, the letters don't really matter here, because what matters is that it's a set with 1 element and a set with 2 elements. You could easily replace any of these elements with, something else. For TR, we could have, the set, or if the set has 1 element, we could have just T, or we could have just R, or we could also have the empty set. Now, what about TRI? Well, when we add an element, we might keep these subsets. So all of these subsets are still valid subsets, right? But we can also add something to each of these subsets, because all of these subsets now all have one potential, other element, I. So if we add I to all of these subsets, those are also valid subsets. And maybe you see where I'm going with this, because in fact, this is actually a list of every subset. So if at each step I can, keep it and then create another copy just with a new element, I'm actually multiplying the number of subsets by 2 by adding each element. So you might think that it's exponential, right? Every time I add a new element, the number of subsets multiplies by 2. That's exponents. And you'd be right, because 2 is 2 to the 1 element. 2 squared, 4, 2 cubed, 8. So the number of subsets of a set with n elements is 2 to the power of n. And that is the really important thing we have to realize. Another way you can interpret this is using the fundamental principle of combinatorics, which states that if you have, n ways to do one thing and m ways to do another thing, there are n times m ways to do both things. For example, if I have 3 shirts and 4 pants, and I want to make an outfit consisting of, shirts and pants, I have 12 choices. I have 3 times 4 choices for shirts and pants. And if I add, 5 socks, that turns into 60 choices. Because now I have 3 times 4 times 5 choices. Similarly, think of constructing a subset. For T, you can either include it or not include it. For R, you can either include it or not include it. That's 2 choices. For I, you can include it or not include it. You see where I'm going with this. 2 times 2 times 2 times 2. You're multiplying n 2's together. That's 2 to the power of n. So 2 to the power of n subsets. So, if you were to apply this formula to BORING, we would say that, well, the elements themselves don't really matter, because what matters is that this set has 6 elements, 1, 2, 3, 4, 5, 6. So the number of subsets is just going to be 2 to the power of 6, which is 64, and that's it. Now, one last thing before you start doing these kinds of problems, always read carefully, because sometimes they will ask about proper subsets. Now, what is a proper subset? Well, a proper subset is just a subset that's not the empty set. It has to have at least one element in it. That's why we call it proper. It has at least one element. But really, there's no modification. There's no big modification of the formula or our approach for doing this problem, because all we have to do is compute the number of subsets and then take out the ones that don't fit. And there's only one subset that doesn't have any elements in it, the empty set. So all we have to do is subtract 1. And so our formula for proper subsets is going to be 2 to the power of n minus 1. Now, let's just apply it here. We have 8 elements, so it's 2 to the power of 8 minus 1, which is 256 minus 1, which is 255. So that's going to be it for this video, where we talk about counting subsets. The most important thing that you remember is 2 to the power of n. And also, for proper subsets, 2 to the power of n minus 1. Everything else, how we derive it, is more of a mathematical curiosity. Of course, I would prefer people to understand where the formula comes from, but this is a very easy to remember formula. So if you didn't understand the derivation, that's fine. If you did, that's wonderful. I'm very glad. But really the important part, 2 to the power of n and 2 to the power of n minus 1. So that's going to be it for today. I hope this video was helpful. Thank you guys so much for watching, and I'll see you next time.